All right. So, and yes, this is the front, but there's really nothing on the front. All right. So let's talk about these three theorems. So the first one we have is intersecting chords. Can someone remind me what a chord is? So what makes a chord a chord? Say it one more time. Right. So it's a segment in the circle. Both endpoints are on the circle. All right. So if two chords are intersected in a circle, the product of the measures of the segments of the chords are equal. All right, so that's kind of a mouthful. So let me explain what that means. So these chords intersect at point E. Point E is kind of where it's dividing the segments in two. So not in half, because they're not going to be halves necessarily, but it just divides them in two different pieces. So for chord NW, the two pieces would be NE and EW. And then for chord KL, the two pieces would be KE and EL. And they're saying that if we took those two pieces and multiply them together for each chord, they would have the same product, meaning they'd have the same answer if you multiplied them. So just to kind of recap, NW separates into NE and EW, and KL separates into KE and EL. And what you're going to do is multiply each of those pieces together and set them equal to each other. So it's saying that if we did NE times EW, we would get the same product as KE times EL. That's what that means. And these pieces have to come from the same segment for you to multiply them together. So KL, you got to have the two segments that come from it. And NW, you got to have the two segments that come from it. So, for example, let's say that NE was 6, EW was 6, EL is, let's say 9, no, let's say 12, and KE is 3. All right, this is just an example. I just kind of pulled these numbers. So if I actually multiply these two pieces, that means I would do 6 times 6 and set it equal to 3 times 12. Which, what's 6 times 6? What's 3 times 12? 36. So they would be equal. Now, why is that important? A lot of times they will give you 3 of the sides and ask you to find the fourth piece, or they'll give you like the next problem that we're about to do where it has some with x's in it and asks you to solve for x. All right, so let's look at number 1. So before we actually do any setup, let's just kind of break down what's going on. So DB and AC intersect at that point, which means that the two pieces for DB are here and here. And the two pieces for AC are here and here. All right. So for DB, how would I write an expression to represent the product of DB? So if I multiply the two pieces of DB, so that would be the x minus 1 and the 6. how would I write an expression to represent the product? So what does product mean? Well, product specifically deals with what operation? Multiplication. So how would I write that in terms of multiplication? X minus 1 times 6 or 6 times x minus 1. Then for AC, how would I write an expression to represent the product of AC? 4 times x plus 3. And remember, these two products should be the same. So how do I set my equation to solve for x? Just set them equal to each other. So I have 6 times x minus 1 is equal to 4 times x plus 3. All right, what's my first step to solve? Not quite. This is just linear. Distribute. If it was a quadratic, we said equal to 0, but this is linear. This would be 6x minus 6 is equal to 4x plus 12. Then what do I do? So we can move the 4x, and you might as well add the 6 while you're at it, just so you have variable on one side, constant on the other. That goes away, and that goes away. So I get 2x is equal to 18. And divide by 2. X is equal to what? 9. Now, if I want to check myself, I can plug 9 back in for x to get those pieces lengths and make sure that if I multiply those two numbers together, I get the same product. So for example, 9 minus 1 is what? 8. So this would be 8. What's 8 times 6? 48. All right. What's 9 plus 3? 12. What's 12 times 4? 48. So they're equal. So it works. So that was the intersecting chords theorem. Now let's talk about the secant-secant theorem. All right, so this is the next one down. So this theorem states that if two secant segments are drawn to a circle from an exterior point, so in other words, they intersect outside the circle, the product of the measures of one secant segment and its external segment is equal to the product of the measures of the other secant segment and its external secant segment. That's a mouthful. Let me just explain in layman terms what that means. So it's all about, this is all about knowing the difference between the whole segment, the outer segment, and the inner segment. All right. So just to wrap our brains around this, our whole segments are, the whole segment from where they intersect to the end of the circle. So our whole segment would be SC, and what's the other one? What's the other whole segment? SA. Good. Outer. All right. So if I say outer, what do you think it's going to be? Outside the circle. So I'm talking about the segment of the whole that's outside the circle. So what part of the whole or the whole SC segment is outside the circle? SE. So SC is our outer. What about for SN? And then lastly, inner. So that means inside the circle. So what are my two inners? NA and EC. Now, These are whole. Now, the main formula is this. It's whole times outer should be equal to whole times outer, where this comes from the first segment and this comes from the second segment. So this is the main formula for that. So that means that we only need to really care about the holes in the outers. Now, one more thing I need to mention is outer plus inner is equal to the whole. All right, that's important. It'll pop up. So outer plus inner is equal to the whole, which makes sense. All right, it's two pieces of one segment. And you think that'd be obvious, but sometimes it's not to some people. All right, so I just want to make that distinction now. So let's look at number 2. So we're going to find OG. So that's what's labeled X. So before I do anything, let's look at the first secant line. So OL. OL is clearly my whole. What's my inner? X or OG. What's my outer? 6. What about for SL? So SL is obviously my whole. So what's my inner? 18. Outer? 8. This is how you should start pretty much all of these types of problems. Now, how long is my whole segment for SL? So the green, how long is that? 26. How do you know? 8 plus 18. So the whole is equal to 26. Now, how would you express the whole of OL? So the length of OL. So what x plus 6 or 6 plus x, either way. So this would be equal to x plus 6. Now, if we're going to do whole times outer is equal to whole times outer. That means I'm multiplying whatever the length of OL is by the length of GL. And whatever the length of SL is by the length of EL. I'm going to set them equal to each other. So this will be 6 times x plus 6 is equal to 26 times 8. All right, so now I can have my equation so I can solve. So first off, what's 28 times, not 28, what's 26 times 8? So if you got a calculator, just put it in. 208. What do I need to do to the left side? Distribute that 6. So what would I get? Good. Then what do I do? Subtract the 36. So if you do that, what do you get? I think it's like 172. Am I right? Okay. And then we're going to divide by 6. Now, this is not a pretty number, so we're just going to simplify that fraction. All right, so what would 172 over 6 be simplified down to? So 86 over 3, good. So if you want to know how to do that in your calculator, you literally just put 172 divided by 6, and then hit math, the math key, and then enter twice. It'll convert to the simplified fraction.
Can I use the bathroom?
Yeah. So x is equal to 83 over 6. And that's what they wanted us to find. So we're done. That's 83 over 3, sorry. That's all they wanted, so that's all we're going to put. Now, if this was a question of what's the length of OL, you would take 83 over 3 and add 6 to it to get the whole. All right, but they didn't ask us for that, so we can stop there. I'm telling you this because you may see a question like that on your test on Tuesday. All right, any questions on secant secant? All right, the last one we're going to do, and then we'll go on break, is tangent secant. So very similar to secant secant, so kind of same thought process. So this states that if a tangent segment and a secant segment are drawn in a circle from the same exterior point, then the square of the measure of the tangent segment is equal to the product of the measures of the secant segment and its external segment. So this is literally just another way of saying whole times outer is equal to whole times outer. It's still that same process. However, first off, on that picture, which segment's my tangent line? So which segment is my tangent? TR. What's true about TR in terms of its whole and its outer? Well, it has an outer, but it still has a whole. But what's true about it? They're the same. All right, the whole is the outer and the outer is the whole for the tangent line. All right, so that's what it means, because for both the tangent lines, it's both the whole and the outer. Whereas the secant, same business. So SR is the whole, WR is the outer, SW is the inner. So what happens is that if we did SR times WR and set equal to TR times TR, it's just the same thing as SR times WR and then TR squared. Because remember, if you multiply something by yourself, it's the same thing as squaring it. So in all honesty, as long as you still remember whole times outer equals whole times outer, you're fine. Okay, you just have to recognize that with a tangent, it's both the whole and the outer. So a tangent line, because it goes on forever and ever, it never goes in the circle. It's both the whole segment and the outer segment. There's no inner. All right, so let's look at the problem. It wants us to find BC, which they labeled X. So first off, let's just label our wholes and our outers. So which one's my tangent line? MA. So MA is my tangent. So this segment right here is my tangent, which means this one is my secant. So what's my whole for MA? 10. What's my outer for MA? Also 10. What's my whole for MC? It's MC, which is X plus 6. Good. Sound together. What's my outer? Outer. 6. My inner is X. So the X plus 6 comes from when we add the outer and the inner together. So now I'm going to put into whole times outer is equal to whole times outer. So this would be 6 times X plus 6 is equal to 10 times 10. So I could rewrite this as 6 times x plus 6 is equal to 10 squared. All right. So how would I simplify the left side of the equal? What do I need to do first on the left side of the equal sign? Distribute the 6. This will be 6x plus 36. What's 10 squared? 100. Now we can just solve for x. So what's my first step? Subtract 36 to both sides. I get 6x is equal to 64. And then I divide by 6. Now, again, 64 does not go into, or 6 does not go into 64 nicely, so we're just going to simplify it down, which that should be 32 over 3, I think, right? So that would be our answer. It's not too bad, but a lot of people get kind of confused on the whole outer inner thing. It literally means what it means. It's like what part of the segment's outside the circle, what part of the segment's inside the circle, what's the whole segment. All right, so here's what we're gonna do. That's pretty much it for notes today. So what we're gonna do is we're gonna go on break. Don't move yet. When we come back, we're gonna go to your graphic organizer. I'm gonna tell you how you're gonna deal with that. All right, so go ahead and take your 3-minute break. Nope. That's fine.
Is it fine if I go back then?
Mm-hmm.